Welcome to a class act navigating the AI landscape. We're well into season 2 now. Really excited about this one as always. Great guest today. And we've had a range of guests from builders, founders, enterprise leaders, all across the board. Every one of them at the cutting edge of AI. So stick with this one. I think you'll really enjoy it. Today I'm joined by Stu Kennedy, who spent 25 years at the intersection of mathematics, music and software. He's a film composer, a core HTMX contributor, and now one of the engineers solving real-time voice AI in production. In this episode, he breaks down why most big real-time voice AI platforms fail outside the demo, why latency is a per-stage problem, not an end-to-end one, and exactly how a single senior engineer with the right tools can now outship a 6-month procurement cycle. Stay to the end where Stu shares one action that will change how you walk into every vendor demo. And remember, if you're finding value, follow the show to support us to continue bringing these conversations to you. So let's get right into it. So welcome to the show and good to see you.
Thank you very much.
Yeah.
Lovely to see you.
Stu, you've had 3 careers braided together, maths, music and software. Most people don't combine those. How does a composer brain feed into how you approach AI engineering today?
Good question. Well, probably helps you to understand some of the madness that is me and where I came from. I've always had an obsession with simulation and the real world, trying to emulate the real world with technology. So even from the mathematics that I did, that was related to fluid mechanics and simulating fluid motion, mixing. So when I studied for a PhD, I did the study of atherosclerosis, which is heart disease. So it's looking at blood flows, looking at the nature of blood flows and mixing. It was chaos theory. So it was really interesting stuff, but it was all about trying to emulate a real world thing with technology. I was a musician as a teenager. I was totally obsessed with trying to make things sound real, like my piano. It needed to sound like a real piano. Yeah. I wanted to play strings on my piano, make it sound like a real orchestra. So I've always had that kind of thing of trying to make something sound real or make something look real. And when I got to the end of the PhD, I was writing it up and I'd got the opportunity to go into the film industry. It just came out of the blue. I made some friends with people on Twitter who were in the movie industry. David Arnold, who is the James Bond composer, and he did Stargate and some other amazing movies. He did the BBC TV series Sherlock. He heard some of my stuff and said, would I like to join him on his music team on the Narnia movie and Harrison Ford movie? And I was like, that sounds amazing. So I was in the write-up stage of my PhD at the time, and I thought, I'm going to do the film thing. So I just abandoned the maths where it was, and I went off and did music for a number of years there. So it was a total transition. I'd been in software before that. I did a maths degree, been building software for a number of years before I went and did my PhD. So I was kind of moving around into different areas that I was really interested. And then I got into the music. That kind of developed. I was working on movies and film, TV shows, adverts, that kind of thing. My realization at the time was that it was very difficult to get hold of these libraries that composers use. So they have like their keyboard and sit at the computer and you're writing using these virtual instruments. And these virtual instruments you buy online, they're very expensive and they're very big. I couldn't really afford them. So what I decided was there was a hole in the market. There wasn't an easy way to get these instruments. So I built a system for downloading them, and I approached the vendors and I said, listen, I noticed that it's really difficult to get your product. Would you like a system for downloading it? They're like, absolutely, it's a total nightmare. I said, give me all your sound libraries in return and I'll give you a download system. So that's what I did. I did that with all the kind of leading sample library developers. So I had the sample libraries that people like Hans Zimmer and others were using that were worth thousands, but I didn't have to pay for it. Yeah. And so that's what gave me the opportunity to start competing at that higher level with the music. Got into the music, and then that company started developing more and more, became quite successful. And so I moved out of being permanently writing and composing on movies to run the company. Still kept my hand in doing bits here and there, but I focused more on the tech side of it and built that up. And then over time, I got more into platform development, platform engineering, And I did that for a number of years as a consultant. And so all of the skills were piling on top of each other until AI came along. That's when I got interested in the next thing, which was voice AI. So this is the next kind of emulation interest of like, how do we make a computer emulate a real person, both in speech, and obviously I've been working with audio, I've been working with mixing music over the top of dialogue, a Foley, which is like sound effects and things like that. So I'm used to these kind of problems, these audio problems, these sequencing problems, alignment and that kind of thing. So this was a kind of familiar territory, and going into the voice space was something that was quite interesting. And so that's like a whistle-stop tour of the kind of meandering route that got me to doing that. So I've been building a lot of voice pipelines. I've been helping people with orchestration layers, and I've been working with video avatar stuff as well.
Amazing. Fascinating background. That's what I love about technology and AI. It's like the different people from different backgrounds and what they've done before and just bringing it all together. I think this is a perfect example. And you've been a core contributor to HTMX, which is a very distinct philosophy: small, composable, server-driven systems. But looking at like voice AI, it is fundamentally an audio problem before it's an ML problem. But most teams approach it the other way around. What do you hear in current voice agents that ML first teams are missing?
I think there's a few things. I would say that there's the issue of understanding audio properly, so capturing audio properly. There are a whole raft of things that you don't take into account when you're just building models and having input coming in and processing it, getting output and measuring that and saying, hey, we've got a good model that does something. There's a whole bunch of things that happen downstream that you need to understand. Are you just using single channel? When we're speaking on this conversation, I'm using my microphone here, you're using your mic, but at my end, I'm getting audio through my sound card or through my speakers, and my computers are also getting audio through from the mic. Now, a lot of providers, a lot of people who are solving this problem will mix those together and send them down the pipe. You've then got a kind of combined single audio channel of two people speaking. Now you've got another problem: who's speaking and when are they speaking? That's called diarisation. That's a diarisation problem, a problem I'm working on at the minute. But you've got AEC, which is acoustic echo cancellation. It's the kind of thing that happens in your browser or on your phone. It's an interesting problem because I'm speaking to you without headphones at the moment, so I've actually got audio coming out of my speakers. And I've got my microphone here, which is also picking up not just my voice, but the audio that's coming out of the speakers. That does cause a problem because you can get feedback. If you're a sound engineer, you'll understand that what's coming out of a speaker and going into the microphone could create feedback, but it also creates a problem with voice. I'll be getting two signals then. If I was speaking to a voice agent, it'll be getting both my voice and its own voice coming back to it. So how does it know what's me? What is its own voice? And echo cancellation deals with that. And it's a well-known problem. It's been solved for many years. But those are the kind of things that need to be built into these systems. If we feed the model garbage, we're going to get garbage out of it. So you need to understand some of these processing pathways, things like noise reduction as well. There are some really good models out there now for doing noise reduction. There's a company called AI Acoustics in Germany, and they've got something that feels like magic to me. Having come from the audio field, you have a very dirty audio signal, maybe of somebody speaking out in a hallway or far away from the microphone. You have lots of reverb in the room. You have background noise and all sorts of interruptions coming in. And their models using AI are able to isolate the main speaker and remove all the background noise. But you've got to be careful because you can remove noise from the background and have a clean signal and think that you're doing a good job by creating a nice clean signal for your model. But if the model's trained on noisy signals, which it more likely is, with natural background, ambience and things like that, it actually might produce worse results than if you gave it the non-cleaned up version. So all of these things have to be taken into account when you're looking at voice AI things like prosody, there are understanding of how the ear works, how the voice works. Prosody is what we talk when we're talking about the pitch and the timbre or the pacing of your voice. It's like the sound of your voice, not necessarily the semantics and the things that you're saying, but the tone of voice that you're using. Lots of voice AI can't pick up on that, because if it's just transcribing what you're saying, it's just getting the words for what you're saying. It's not understanding how you're saying it.
Yeah.
And there's a lot of meaning that's carried in the way we say things, sarcasm and disappointment, or one sentence can mean two totally different things in the way that it's said or the way that it's paced. And so we've got to use the information available to us. I think most teams are feeding the ML models compromised signals and hoping it's smart enough to figure it out. But I think the companies that are doing really well at it are taking all of those things into consideration.
That's what I was thinking. It's not one of those people that working in different forms of technology and AI, maybe just moving into voice AI. There's a hell of a lot there that they would need to really get their head around and master. So it's probably quite a niche area as well for people like yourself who really know it inside out, which is good. Because you've spent years mixing dialogue, music and Foley, getting everything to sit perfectly in a scene. Now you're working on a real-time diarisation of Pyannote. Is that essentially the same problem, just in different clothes?
Yeah, it is. It's basically you're taking a lot of these concepts and these principles that you use in the audio space, then you're taking them into this technical application. I mentioned audio echo cancellation before and how that works. That's basically the same as what we used to call sidechain ducking. Hip hop producers and all sorts of every producer uses a sidechain ducking where let's say you've got like a big track going on and then you've got a kick drum coming in. To really make that kick drum stand out and to punch through the mix, because you've got all this other noise in the track, you have a special presser that listens to this kick drum and then it ducks the rest of the track out just as it's punching. So you get like this, and you'll hear it in a lot of tracks where you kind of get this ooh, ooh, where it drops down, and you can hear it from another room where the audio levels drop as the kick comes in. That's sidechain ducking. And so that's effectively what we're doing in echo cancellation. It's got some more steps to it, but it's those kind of like engineering problems that have been solved before that have now got a new life in a new field. And composers and music producers have been solving these problems since the 70s. But kind of what's fun is like now doing it in flight, on a live stream, and you don't get a second take. So you can't go back and redo it. These are systems that have to work live on phone calls or on video chat and things like that. So it's an interesting problem.
No, definitely. How did you end up at Pyannote, and what's the streaming diarisation story?
Okay, I have a number of products that I've been building over the time that have been trying to push the envelope of transcription and diarisation, which I explained earlier was the identification of the individual speakers in the chat. So if we were to diarise this conversation, it will show, here is Stu speaking, and here's Michael speaking, and here's some overlap here between when they were speaking over each other. And so you get this kind of separation of the different speakers and then who they are. Now, if you've got a meeting that you're recording of like 10 people in the meeting, that's a difficult problem. And you need to be able to track those speakers, and you need to be able to identify them when they come back later. If you get that wrong, there's all sorts of problems depending on your application. Let's say it's a legal application and you're transcribing a courtroom. Not sure that's been done yet because of the legal ramifications, but these are the kind of applications we're moving into where we need to be able to accurately assign that person said that and that person said that and have the model do it. So diarisation does that. And I was building a product called Callwell, which is effectively something that's designed for account executives in sales who are on a phone call. And I find that when I'm on a call, I can go a bit blank and I'm like, I don't know what to say. And I'm thinking, maybe I say the wrong thing or go down the wrong path or whatever. I wanted something that would help me on a sales call for my products. So I built this thing that would listen into the call, and it was giving me advice as I was going, saying, hey, mention this, mention that. Oh, don't talk about that. Let them ask more questions, blah, blah, blah. I'd be having a field day right now if it was on. And the problem that I needed to solve well was this diarisation problem of who's speaking and when, because the transcription one is a well-solved problem. We can get pretty accurate transcription back, what people are saying, but who's saying it is a harder problem. Then we need that quality of information to be able to pass to the LLM to, you know which one of these I am, so what advice would you give me right now? Rather than it thinking that I've said something I haven't. So I got stuck with that problem, and I thought the best thing to do here, I'm going to go and help build the solution. I know Pyannote, these guys got some of the world leading batch diarisation, which is, they do it offline. That's where you can upload a file and it'll do it. And I wanted it in real time. I wanted it as you're on the call. And so I was emailing them saying, hey guys, are you doing streaming diarisation anytime? And they're like, we're looking at working on it. I'm like, can I come and help? So they were like, yes, please. I've been working with those guys, helping them. It's been a blast. And I've been able to introduce Cloudflare to Pyannote, which is the platform that I use for doing a lot of my real-time orchestration. It's not very commonly used. Most people are building in Python and managing their own infra. Cloudflare for me was a big unlock to how I build voice pipelines. So I brought that in to Pyannote as a solution for their architecture for streaming, and we're currently building that, and it's going great. So I'm quite excited about that.
And it's obviously we took some of your work down to the Scottish Government, had a leadership AI trip in London, and my colleague Mo, I think, showed a few of your demos, which went down really well. Is that just that if you see something and you're interested in it and you're like, you want to know more about it, do you just kind of like contact these people and just ask to work with the senior leading engineers? And is that kind of stuff obviously you would go and do as like more just kind of education and learning from you rather than as a contractor, or a bit of both?
Yeah, that's for the last 15 years I've been contracting. I'll be working on my own products, and then I'll tend to have a day job where I'll be working for somebody else. I helped out Anam last year. They're on the NASDAQ now. They're going big. They are the video avatar guys. I think it's world-class. It's the best real-time video avatar solution I've seen. I came about it because I was using it and building a product called Medicend, which is some students from Dundee University approached me. They had an idea for building a real-time AI video training platform for medical students. And they wanted the medical students to be able to practice their OSCE exams and going through a clinician's can interview a potential client and patient. So the patient is presenting with symptoms and talking through all of their problems, and the trainee doctor is meant to be able to diagnose them and go through all of the rigorous steps that they're meant to. So they wanted a platform built that could do that, and there was nothing out there that did anything like that. But I love a challenge. So I'd already come across Anam, who are some of the devs had worked at Synthesia before. They were kind of bleeding edge development with real-time video generation. And so Synthesia was focusing on offline kind of video generation, but these guys went off and focused on real time. So I built a system for these guys. There's medicine guys that took the real-time experience and allowed you to have this video avatar thing. In doing that, I was finding limitations to it and things that I'd love to improve. So I contacted the guys and I said, listen, I'd love to come and help you. And so I went along, helped them make the orchestration layer faster and things like that. Worked internally. They're a great team to work with. They've released a new model recently, which is Cara 3, which is really exceptional. So if you've not seen Anam's stuff, go and have a look, because it's magic.
I love that attitude as well. And just quickly on this, I was just thinking about it. Like, one thing it comes across with anybody I've been doing the podcast with, like people that are kind of top of their game anyway, and like really pushing forward with their careers and development, the amount of learning you guys and women must do, like, just to really keep up to date and just to be top of your game.
I think you get caught up
Yeah.
in the fun
Mm-hmm.
of the challenge of how do we make this impossible thing happen.
Yeah.
At Pyannote at the moment, the whole team are like that. There's an excitement and a buzz
Yeah.
about when you have a new breakthrough, you improve the latency so it's faster and more responsive, or it's more accurately picking out people. Every improvement creates this buzz of like, we're getting closer to something that is magic. And I think that's the appeal, that creating things that solve these problems. There's real problems to solve that we want to solve, but there's an element of magic to it. There's an element of kind of, this is quite exciting. I think everybody who's in AI has got that level of kind of childlike excitement about it. Every time you speak to an LLM, it's magic to me. I worked on some AI concepts back in my early maths days. I was working on an AI problem and it was going nowhere. My personal view is that we would never get anywhere with AI. I just didn't think, I thought it was going to be one of those kind of unsolved problems that we were just never going to get anywhere. And it was only a few years ago. It took me a while to really, because I'd seen machine learning models and neural nets and things and thought, yeah, that's cool. And probabilistic systems, and I'm cool with all of that. But the idea that you could actually get something that would understand what you're saying and would be able to reason through steps and come out with solutions, I just thought we would never get there. And we are way past there now. It's quite an exciting time to be in the dev space.
Love it. I could stick to this topic for a while now, but we better move on with it. I've got loads. I'm even writing notes and thinking about different things. But anyway, so there's the visual side, avatars, lip sync, facial micro expressions. As someone who's scored to picture, you know how unforgiving sync is. What's the honest state of avatar realism right now?
We're past the obviously fake, uncanny valley. There are still a lot of providers out there that are doing the kind of uncanny valley, not good enough thing. But there are some people who are pushing above and punching into the, wow, that feels like a real person now. I think some of my recent conversations with the Anam avatars were spookily real, and you feel like you're getting actual reactions. When it's fast enough, there are a number of things that are going to feed into that. I think we focus a lot on latency and the speed of response. That is an important factor when you're talking to somebody. If there's a really long pause after you finish speaking and somebody responds, or visually they don't look like they've clocked what you're saying, that's a problem. And so getting the latency down is a challenge. And it's a really hard problem, to be fair, because you've got a lot of things happening in sequence for these models. You've got transcription, you've got turn-taking detection, which needs to predict when you finish speaking. If I take a pause in the middle of a sentence, and so I say, oh, I'm thinking, where should I go? Now, a model that doesn't understand that I'm halfway through a thought and try to finish that off will just interrupt at the point where I leave a gap and go, I'm thinking, and it'll say, what are you thinking about? And we've all experienced that when we're trying to use some of these voice models. And I feel that they put you on edge, actually. They give you an anxiety because you feel that you're going to keep speaking really fast and keep using filler words all the time. And that's because it's poor quality voice AI. And the realism comes from a whole bunch of different things. One is the speed of response. And most of these voice pipelines are actually quite slow, even though they advertise like fast. Most of them in reality are taking a few seconds to come back to you. The other thing is turn taking, like I just mentioned, the fluidness of the conversation, the comprehension of the LLM so that it understands what you're getting at and not just the semantics. And especially in a video context, there are visual cues as well as to how it's appropriate to respond to somebody. All of those things play into video avatars. And so it's a really difficult problem, but it's getting closer and closer. And these models like the Anam model, which has got I'm not sponsored by them, by the way. I just think they've really got something that has pushed into another level of realism. And when you're talking to something and you forget that you're talking to a computer, to me, that's the Turing test. So I still think we're not quite there. There's still some speed things. There's still other things, control over the emotions coming back to you from the LLM, because you've got different stages in the voice pipeline, right? You've got the understanding of what the user's saying, and then you've got the processing of what the response is going to be, and then you've got the speaking out or the acting out of the response. And so you kind of got those three sections. You've got other things that can happen as well, like function calling. Say it needs to go off and check something in a database or needs to action something. That those things are all built in. So it has knowledge bases and there's a whole bunch of stuff that happens, but that's in the kind of LLM space there. But it impacts all these other things. So let's say, for example, I'm talking to a customer support agent and I say, yeah, I'm having a problem with my computer and it's doing this, that, and the other. Now, if the agent goes off to go and check some details in a database and then checks its knowledge base and then comes back to me, that could take a good few seconds. They might have said, hey, can you tell me what's wrong? And I say, yes, this, that, and the other. And then I'm sitting there waiting while it goes off and checks its database. And to me, I'm just getting a nothing. I think, are you there? Are you broken? Whereas there are clever ways of being able to asynchronously respond to the user and say, okay, let me check that first. I just need to look up some things. Okay, looking up on the database, I can see that you've got, and so you have more of an interactive process. And so there are lots of things that aren't just about the model or the realism and aren't just about understanding, that are to do with the interaction of the voice agent that make it real. So there's a lot of different factors at play. How well is it understanding me? How well is it understanding the problem? How well does it have access to knowledge and access to the things that it needs to do? And how well is the flow of the conversation going? Is it a natural flow? Does it know when to let me carry on and finish? Does it know when to dig deeper? Does it know to tell me that it's doing something that's going to be a blocking process? And then how is the output looking? Is it realistic? Is it expressionate? Is it able to accurately portray all the different ranges of emotion that it needs to do?
Fascinating, that is, honestly. And you've talked about cutting ASR latency from around 2 seconds down to 350 milliseconds. Why is latency such a hidden killer in voice AI? And what actually happens inside that 2 seconds delay?
The latency issue is, it's an interesting problem. Under the hood, there's so much going on. And so from your microphone down the wire to your sound card, through your computer, up through the browser or whatever application you're using, there's buffering and network jitter and all sorts of crazy stuff going on. And then you've got a whole of different models that are being called. So ASR is auto speech recognition. So that's like another name for transcription, right? But that kind of encompasses more than just speech recognition, more than just the words now. It tends to encompass the turn taking as well. And there's a lot of model providers like DeepGram, Assembly AI, Speechmatics, I think, do it. Gradium is a new one on the scene. They've all got models that do the transcription. They recognize what you're saying, but they're also got some form of turn-taking detection built in. Turn-taking, last year, everything moves so fast here, but last year it was typically like VAD, which is voice activity detection. That's just like an audio engineer type solution, which is, can I hear a signal or not from your microphone? And how loud is it? And how long is it on? And yeah, we think you're speaking, and now you're not speaking. And so that's just voice activity detection. Are you speaking? Problem with that is it's very flawed. And so if there's a dog barking, or I'm typing on the computer, or my chair creaks, or I cough, or anything, it'll think that's me speaking, and then it interrupts the whole flow of everything. So VAD just wasn't a good enough solution. Turn taking is now being built into a lot of these applications. So now you've got these multiple processes happening in one step. So you now have to have the audio signal come through from your mic, through your sound card, through your computer, up to the server, be sent from the server. Usually, if you not got your own model, which most people don't, they're using a API to Deep Grammar or somewhere like that. You're now going to stream that audio through to the model provider, who are going to process it on their GPUs, and they're going to send the text back, and they're going to send other things like, hey, it's the end of turn, or it isn't the end of turn. And then you've got to punt that into the next stage of your pipeline, which is your LLM. So when you've got an end of turn, it goes, okay, Michael said this, it's the end of his turn. Now let's think about it and how we're going to respond. It's not the same as how a human works. A human's listening all the time. So you could speak for ages like I am here, and the AI is listening. A human is listening to what's being said and processing it and thinking about it, and maybe thinking about a question that they want to ask at the end. Whereas the AI typically is waiting till you finish, till it gets what you've said. At that point, it then has to process everything you've said and then come up with a response. And then it has to find a way to speak it out, which is the text-to-speech bit. And so you've got all of these kind of daisy-chained processes that are back-to-back that take time, and the communication channels between them all adds up to latency. So that whole pathway, and you can imagine there's a lot of stuff in there to get all the way from my mic through to a server, through to another server, process on a GPU, back to that server, off to another server to do the LLM, back to that server, off to another server to do the text, back, and then back again till I've got audio. It's totally doable. And with platforms like Cloudflare, with LiveKit and PipeCat, which run on Python, you can put all those things together, and these models are super fast. And if you stream everything, if you are clever about how you call things and how you run your infra, but it's a big engineering problem. So yeah, getting things down, and it's often to do with understanding the full holistic problem, but often it's finding a solution that's already out there that might be solving the problem in a better way. And so you can get into a blinker of, we just need to chop these latencies down, because latency is introduced at every single stage. Maybe there's a model that does this whole bit in one go, and we can replace this whole section. So there are ways of solving these problems by thinking outside the box a bit. But yeah, it's a difficult problem.
Mm-hmm. No, it definitely sounds it, 100%. And the big voice platforms like OpenAI Realtime, VAPI, Retel are all pushing turnkey solutions beyond the happy path demos. Where do they actually break into the real world?
Yeah, we're basically seeing companies who start off solving a problem, usually, which is maybe the ASR, the transcription problem. Maybe it's a Deep Grammar or a Cartesia or 11 Labs doing text to speech, or somebody doing video like Anam or HeyGen or one of these guys. There are ML engineers generally who've built models that solve a very niche problem, and they're building kind of the state of the art in this particular thing. Now, the problem they've got is adoption and friction with the market. How do they get engineers to use this? How do they get enterprises to start using their product? And so they tend to have to go down this turnkey solution kind of rabbit hole where they need to build out a whole pipeline solution that they can present as a turnkey solution to their customers. And it becomes, you can self-sign on and you can get going in 5 minutes, and you've got an agent framework, and it's great. I can do voice AI with Deep Grammar, or I can do voice. And so what they've moved from specializing in one area to building the voice pipeline, and then often they'll start dabbling in these other areas as well. So instead of just, maybe they're a text-to-speech company, but now they're doing ASR as well, and they're doing turn taking, and they're dabbling in LLM as well, and agentic platform and function calling and kitchen sink. And so everything gets poured in. The problem is you end up with a kind of problem with scale and maintenance. So the way that ML engineers are typically building initially is like Python solutions, because that's how AI solutions are built with Python. it becomes very easy to just build out that Python model and build an infrastructure around it and then make that into a product. And then that sits on a server. And so you got Google Cloud or something, and you've got some GPUs running your model. It's very difficult to scale these kind of tightly integrated and tightly coupled orchestration layer model solutions.
Yep.
And that in itself is a problem, the scaling and the maintenance of that and being able to decouple. It's getting better because some of these companies are taking on Pipe. I keep getting them mixed up, but PipeCat and LiveKit are the two kind of main solutions out there that people are turning to, which allow them to do Python-based scaling infra. That is a good solution, and that's gaining more traction. But I don't think there's been enough time spent in places like Cloudflare, which are edge network solutions that can do real time really well. They've got zero cold boot. You don't have to scale and maintain scaling solutions. You don't have to work out how all the different network hops work because their internal infra is so unbelievably fast. So there are different solutions out there, but the turnkey thing is a problem from that perspective. But the bigger problem, I think, from it is the use case blindness. So you can never really handle the breadth of real world use cases by building a turnkey solution. You end up just hitting the happy path of like, how do people expect to use a voice AI? Or they'll have some RAG, some knowledge that they want to upload. They'll have some function calling that can run in the client or whatever. But you're not really understanding, you're not solving a specific problem. You're just trying to create like a hammer that can solve as many different problems as you can. And when engineers get started with it, they're like, great, I can create a demo and it works. It's fab. But when they start trying to apply it to their actual problem, they start to hit all of the kind of dead ends and think, oh no, we're going to actually have to go back to square one and build our whole solution internally. And we're going to just have to grab all the independent little models and stitch them together. And so I would like to see some of these companies focusing more on the kind of products that they're really good at building and put their energy into just making those exceptional. Because really, at the end of the day, you can't really solve all of these kind of integrated problems in one platform. And now we've got like about 10 to choose from, and it's impossible. But I think the way that it's going to work is that you're going to want to shop around a little bit for different things that depend on what works best for your solution. I want a speech to text, a transcription engine that works like this because I'm doing medical stuff and it needs to be exceptionally good at that, but I'm not too bothered about the speed. And I want an LLM that does this, but it doesn't do that. And I want text to speech that works like this. And so you want to put these things together in a way that works for your product. And so I think what we're missing is the quality and the flexibility of the independent parts, rather than just these kind of everybody putting their energy into making fancy, like, just stick me on, here's a little bit of JavaScript that you can stick on your website and you've got a voice agent. And it's a nice gimmick, but it's not going to really solve the problems that people are wanting to solve.
No, ideal. If a CTO is listening to this show and they need something real, not just a demo, what should they actually be doing instead?
You need to own your own audio pipeline. I think that from day one, the audio is the product. There are lots of things that you are not going to think about when you're starting out building your voice pipeline that you are going to need really quickly. Things like end-to-end telemetry and observability, things like the ability to record as the user would hear it. That's a much more difficult problem than you think when dealing with voice AI pipelines, because of the asynchronous nature of how all of the audio is generated. It isn't generated in the way that you experience it. It's generated quicker than you experience it. So there are all sorts of really complex engineering problems. And I think if you own the pipeline from day one, you get to choose the things that are important to you and you don't get locked in to a vendor solution. And that can be a problem, because not just because the market moves on and there's better solutions that come along, or because you find out that there's a limitation to it, but often these vendors are switching their priorities as they're going along and they're deciding that they want to focus on a different area. maybe the use cases that most of their customers are using is different to yours.
Yeah.
And so now they're going to drop the kind of thing that you're critically relying on, and they're going to focus on something else. So I think the ability to choose and not have vendor lock-in for different solutions, to be able to easily plug and play different transcription solutions, different turn-taking solutions, different text-to-speech solutions, different LLMs, building in such a way that you can easily swap those things out. Maybe you're using Anthropic, and Anthropic go super expensive compared to everybody else, and you think, wait a minute, we don't want to use them for the LLM layer anymore. We want to use Gemini or somewhere, or OpenAI. You've built the system in such a way that it's easy to swap out, and you're not relying on that whole thing. And the observability thing is really important as well. Being able to instrument latency at every stage of your pipeline, so you can see where things are going wrong, so you can see where sometimes it's not obvious. You assume that the LLM's the thing bringing in the latency, but there's something else bringing in the latency, or there's a network hop that's happening. We had a really interesting one recently where we thought we were speaking to a local GPU. So there's a model on the GPU that we want to call, where I'm sat at the computer here. And so here I am in Scotland. I want to spin up a GPU that's close to Scotland. So let's say we could spin up a GPU in Edinburgh, right, which would be ideal. So I can, from my Glasgow base, I can send a request through to this GPU in Edinburgh, and the network hop is about as quick as you're going to get it. In reality, what was happening is the GPU provider has got a complaint over in East Virginia or West Virginia, US East 1, which is all the way over the pond. And so your data is going from Glasgow all the way over to America and then all the way back again. And you wonder why it's taking ages. And there are things like that are difficult problems to deal with, and you don't know what's going on under the hood in somebody else's pipeline. But if you've got control over it and you've got telemetry, you can see what's happening, then you get to control that.
Oh, brilliant. Love it. And you've said that we're moving from no code to agent assisted high code. Are you generally saying a single senior engineer using tools like Claude Code can outship a traditional SaaS procurement cycle?
Yeah, I jumped heavily into the coding agent stuff about a year and a half ago, and I haven't looked back. There was friction at first. It was difficult, but I could see the potential for being able to delegate difficult parts of the development cycle to a coding agent. Things like doing reviews and double checking code, but also helping me do the discovery part and planning what I'm going to build and making sure I don't miss use cases and things like that. And then there's just the boring replication of boilerplate code that I've got a framework that I'm using, and I've got my preference. I use Hono on Cloudflare for a lot of my stuff, and I have a way that I like to build, and I have a way that I like to declare endpoints, and I can teach my coding agent how to do that, and then I just need a new endpoint, and it just makes it. That was already starting to be a thing last year. Now we're at the point where it's more like I'm running a dev team. When I'm building my own products, I'm basically like, go off and build this, and these are the guidelines, and then I have all sorts of checks and balances in place to make sure it's doing the right thing, and I eyeball the code and I make sure it's right, but I'm leaving it to it, because for me, it's making sure it solves the problem and making sure it's maintainable and reliable and it's going to work. So definitely getting that from Claude Code and Codex now. I kind of hop between the two of them. Spec generation and all those kind of things is good. The kind of review loop is good. It keeps the quality good. I'm getting great results from that. And to be honest, wouldn't be able to do the level of implementation and volume of deploy that I do. Context switching between things as well becomes way easier when you've got coding agents maintaining the context of this is where we got to with this and this is where this was. So yeah, coding agents are great. Great tool to use. I have an OpenClaw instance that I run in my garage here on my Mac Mini. I can contact that from Slack and I can talk to it and I can ask it to do things. It can spin up. I know that Claude Code has been banned from being used by Anthropic has stopped OpenClaw from being able to use it in the print kind of way that it was using the agent before. I have a way that I use it, which is as a PTY, which is effectively like a normal terminal instance. So my OpenClaw starts up a normal terminal instance of Claude Code, which is totally legit. And then it just checks in on it and reports back to me. So I have it working like that. It can carry on tasks while I'm busy on something else or away from the desk, or during the night, it can go through and tidy things up. And so it's a really powerful thing to have, honestly, especially when you're integrating with people's systems that you haven't seen before and you're getting onto a new code base. You're trying to understand how their architecture works and how your solution might fit in. It's been absolutely invaluable to be able to go in and understand the code base immediately. So yeah, coding agents, the kind of Ralph Wiggum thing that was big last year, which is just part of every platform, that coding agent platform now, that iterative loop of going around. I've been using that for a good while and it's been getting good results. So I'm quite happy with that. I know there's a lot of engineers who sneer at the idea of using coding agents. I've been developing for a very long time, and my view now is that it's definitely doing a better job than I can on a lot of tasks.
Yeah, I've been thinking a lot about this lately as well. We could do a full podcast on this. I'd love to really delve into a bit deeper with that. So maybe get in touch with you about that. And it's just an interesting subject, it really is. As you say, there's a lot of debate going on, a lot of people talking about it, but we'll leave it there. But you've described LLMs as non-linear systems, small changes, big swings. How do you actually constrain something you can't fully control? And is there a parallel with how a composer constrains performers to get the outcome they want?
LLMs are non-linear systems. They are probabilistic in their nature. They don't have an entirely predictable outcome, but they have think about them like the attractors in chaos theory or whatever. They're a kind of force that's pulling things in a certain direction. And so if you understand the nature of these things as a kind of fuzzy attractor rather than a function that you put something through and you always get the same output, you can start to work with these problems in a much more creative way. Obviously, music is creative, and the kind of programming that I like to do is quite creative. And I think you've got to get used to getting your hands dirty. I do oil painting for fun, and when I was learning it, it's not great for somebody like me who doesn't like mess, a bit OCD. And I forced myself to do it as a kind of like, you need to get good at this stuff. You're working with stuff that doesn't do exactly what you want. And it reminded me a lot of composing. When I'm composing for orchestra, the way that you work is in these big kind of brush strokes of, this is the palette, this is the sound, this is the color that I'm after here. And then you put down something very rough, and then you iterate through it and you work it down and get the detail in the places that you want. It's the same with painting. You don't put detail everywhere, you put detail where it's necessary. And it's the same with these kind of like solutions with models. You're not trying to control everything. You're not trying to force everything down in like an old school engineering pathway to be able to test every single thing that comes out. What you're wanting to do is you're wanting to have a predictable outcome at the end that has a quality that's above the threshold that you're bothered about. It's got safety above the threshold that you're bothered about. And so these are very difficult problems to manage, and getting into AI safety and those kind of areas are big Pandora's box. But when we think about AI and LLMs in that sense of like, it's an attractor rather than a function in that respect. But that's not something that we need to be scared of. Quantum computing and other things all deal with computing with uncertainty. And I think that's an area that we're going to get more into.
And for a CEO listening, what's the single biggest mistake companies are making right now with voice AI?
I don't think there's a single one, but I think if we cheat, we're just treating like voice as a chatbot with a voice. Do you know what I mean? We've got to understand the whole paradigm of voice and not just think about it as, hey, I'm having a text chat session. let's shove a voice on the end of it, and now we've got a voice agent. There's much more involved in a conversation and a voice conversation than there is in a text conversation. And the dynamics of that, how it works, how it goes together, things matter that didn't matter before, like latency, like timing, like tone, like understanding how you're saying things and how it should be spoken out. And so the level of complexity goes up an order of magnitude really over just a chatbot. I think picking your LLM, that matters. It's a bit like if you're picking a singer or something. If the room sounds terrible and the mic is broken, it doesn't matter how good the singer is. You're going to get a bad result. So understanding your whole audio pipeline, how everything plays together, it's never just down to one component of being good. It's about the whole thing.
Love it. I'm moving on to like you now. Obviously, I don't know if this, we're probably making this public today, but you're joining Multiverse as a principal AI engineer. Why that move and why now? And what does it say about where enterprise AI is heading?
Yeah, I think for me, I've spent a lot of time with different startups and helping companies both building pipelines and helping them with their models. I think my passion is going back to the original thing that I said, which is solving the problems, these kind of synthetic emulation problems, and bringing that. I think helping build the technology is a necessary part of that.
Yeah.
But my bigger passion is actually bringing those solutions in. And I have been contracting now for about 15 years. In fact, since I was in the movie industry. And then I have decided that I'm going to go into a permy role now. I can build solutions. Multiverse is a upskilling and ed tech platform. So they are pushing the boundary in how they can do AI transformation, both internally and externally. And so they're looking at the kind of next stage of how do we get adoption of AI into enterprise? How can we make people ready? And I'm aware, having had a front row seat to a lot of the technology that's coming out and that's being developed at the moment, how transformative this is going to be to the whole world, and especially to people. Anybody who's working with a screen is going to be impacted by the capability of AI models. So I'm concerned. I've got 6 kids and a grandkid, and I'm thinking about their future, and I'm thinking where things are going, and I'm concerned about how we implement and adopt AI going forward. And for me, an important part of that is upskilling and learning how, educating the workplace on how to use AI rather than be crushed by it. As somebody who, I'm an early adopter of things, I always like to learn new stuff and get ahead of it, but not everybody is like that. And there can be a lot of resistance and reluctance to get into new things. And I think I'm quite excited at the idea of being able to help in somewhere that's, rather than finding ways to replace people with AI, finding ways to upskill the workforce to become more productive and maybe to cross skill and to find different ways that they can adopt AI and use it for their benefit without it becoming this scary thing that comes in and infiltrates. So Multiverse is all about that, and I'm pretty excited to be working there on that kind of stuff.
No, I'm super excited to follow your journey, as I have been for a while now, since we first, I think I was looking for a really technical person for a certain position, and I can always remember getting a WhatsApp with your name and says, call Stu, he's your man. Hey, I think you were busy at the time or something, but so it's been good. So if a leader is listening and wants to take one concrete action this week off the back of this conversation, what should they do?
I would say AI needs to become boring enough to be useful. I'd say your users need to stop noticing your AI. It's not about how fancy your AI is or how cool it is or what the solution is. It's like, boring's not the goal, but it's like the end state, right? It's the kind of unsexiness of a solution that just works. And so the most impressive AI systems that I've built that I would say users can't tell there's AI involved. It's if you're doing special effects in a movie, you've done your job when nobody knows there's special effects there. Do you know what I mean? I have a story that I could tell you if I've got time for a wee story.
Yeah.
Back when I was doing composing, I did a talk, the BFI is the British Film Institute for Composers. So a room full of professionals, of music professionals, and they're all working with virtual instruments on computers like I was, and they're using virtual orchestras. And I was one of the guys who specialized in doing virtual instruments. So I was brought along to talk about this idea of getting good with creating virtual orchestras and making them sound real. And I did an experiment with this room. I told them that I was going to play them a mock-up, a fake rendering of a very famous theme tune, which was Back to the Future theme tune, one of my favorites by Alan Silvestri. And I said, I'm going to play you a fake mock-up, right? You're all professionals here. I didn't do it, so I won't be offended. I want you to put your hand up as soon as you can tell it's fake. And I want you to be listening out for all of the different things that you can hear that would give it away as fake. Put your hand in the air. I said, it doesn't matter if it's the first bar or if it's right at the end, just be honest when you can tell it it's a fake. And so I started the track, and within 2 bars, a couple of hands go up, and by 30 seconds, half of the room, it's a few hundred people, hands were in the air. And I stopped it and said, that's the original recording from the movie that you've all heard hundreds. What we're dealing with when we're creating synthetic, whether it's AI voices or whether it's virtual mock-ups, is that people are biased against virtual things that are AI or synthetic music. They think that they know the difference between real and fake. Everybody wants to feel that they can tell the difference between real and fake and don't like to be duped. So if you tell somebody they're going to hear something fake, they immediately assume they can tell all of the weird artifacts and differences that make it fake. And it's the same with AI. One of the challenges that we've got when working with AI is the expectation from the user that I'm about to interact with something fake and it's going to be rubbish. And so I'm listening for all the, it doesn't sound real to me. It didn't say, but I've got a contrasting story. When me and Chris, my business partner, were building voice AI, it's just a couple of months ago, we're working on a voice AI solution, and to test it out, we were integrating it with telephony so that we could phone it from a phone. Now, I'd cloned his voice. So his voice was working on the system, and we had it to train an answering assistant for a local restaurant to take a booking. But just to test the system out, he set his phone to forward his calls through to this system. So I was going to call it, but his wife called as he's got it forwarded, and it went through to this voice AI. And we're watching on the screen as the transcription's going up for her having this conversation with this voice AI. She couldn't tell it wasn't him. She thought he was just being super weird and strange. And so you've got this strange conversation going on with somebody who's been married a few decades, knows his voice, knows the way he speaks, and was like, what are you talking about? What do you mean a restaurant? Was this, are you coming back for lunch? Or it was something like that. And we were just howling because it made it so clear that when your expectation isn't raised that something's going to be fake, and the current technology is actually so good in some situations that it is indistinguishable.
It's frightening. It does frighten you.
That's what we're dealing with. So I think for a CTO, you need to be aware that there's going to be resistance to adopting AI, both internally from your own employees and from your customers. I think you just have to be wise on how you present it to people. Maybe you allow people to experience it without them realizing it's AI for the first time and see how they respond. But keep your eyes open for the best solutions that are coming. And they're not necessarily the ones that shout the loudest or have the fanciest advertising and marketing campaigns. There's a lot of really good models out there that you can stitch together and get something that you wouldn't be able to get with a turnkey solution. So, I'm very excited to see what happens over the next couple of years with solutions coming out that are going to change the way that we interact with doctors' services and all sorts of things. So, yeah.
Amazing. No, thanks, Stu. Honestly, really good. And if
It's
you're
been a pleasure, mate.
Yeah, definitely. And if you're building anything with voice AI right now, I hope this conversation's maybe saved people 6 months of learning the hard way. And if this episode gave you something you can use, subscribe, leave a review, and send it to someone who needs to hear it. We'll see you next time. But thanks, Stu. Really good. Appreciate it.
Been a pleasure, mate.
Speak to you
Catch
soon.
you soon.
Thank you. Thanks for listening to A Class Act. If you've enjoyed the episode, make sure to follow the show so you never miss a conversation. And if you're building a data team or making a key leadership hire, reach out to us at MBN Solution using the link in the show notes.